California's beauty hides a restless world beneath its forests, cities, and coastlines. Shifting faults, ancient fires, and rising ground are quietly reshaping the story of this iconic state.
Well, right now, a warning for Southern California about the increased risk of a major earthquake. Experts say a series of small quakes along the San Andreas Fault could lead to a bigger one, and people in the area should revisit their emergency plans.
California, a name that conjures images of endless coastlines, sun-baked deserts, and dramatic mountain ranges, is more than a stage for nature's everyday spectacles. Beneath its bustling cities and tranquil redwood forests, this iconic landmass conceals a labyrinth of geological marvels, tectonic unrest, and relics from ancient Earth, as well as traces of humanity's earliest efforts to adapt to a shifting landscape. Stretching from its rugged northern cliffs to the palm-lined southern valleys, California's story is written in stone, in fault lines and in fields of fire, a chronicle forged by the constant collision and renewal of the Earth's restless crust. In recent decades, subtle yet remarkable changes have captured scientists' attention. Chains of volcanic tremors, newly mapped faults, and a cascade of surprising geological events spread across North America, with California squarely in the crosshairs. Researchers from disciplines spanning volcanology, archaeology, paleontology, and geospatial analysis now work to document and understand the secrets emerging from riven valleys, breached magma chambers, and fossil-rich canyons. What do these discoveries reveal? Not only about the forces beneath America's west coast, but about our planet's volatile past and constantly evolving future. From freshly exposed craters to remnants of vanished forests, pioneering earthquake mapping, and layers of long-lost human history revealed by shifting Earth, we journey through 20 of the most astonishing geological and scientific discoveries in California. Each reflects not just the enduring drama, but also the ever-unfolding mystery of this remarkable frontier. As fractures widen and ancient clues come to light, one question lingers. What mysteries still slumber beneath California's dynamic skin, waiting for the spark of discovery to bring them to the surface? Chapter 1. The Rumble Awakens, California's Volcanic Potential. In recent years, researchers have documented a notable increase in volcanic monitoring, not only across California, but throughout the broader Cascade Range. While the claim that 21 volcanoes erupted simultaneously across North America is exaggerated, several volcanoes have exhibited heightened seismicity and gas emissions, meriting careful observation. California's volcanic landscape, from LASSEN Peak in the north to cinder cones in the south, has drawn renewed scientific focus due to these subtle signs of potential unrest. Efforts in real-time monitoring have advanced rapidly. Volcanologists use remote sensing to detect gas release and subtle ground deformation, a sign that the crust beneath the west coast remains restless. Portable seismographs, more compact than ever, feed constant tremor data from the snowy slopes of Shasta to the backcountry of Medicine Lake. Communities often report faint odors of sulfur or changes in groundwater, further guiding scientific inquiry. While an immediate chain reaction or catastrophic transformation is unlikely, California's dynamic network of volcanoes is now better understood as complex and interconnected, potentially capable, over geologic time, of reshaping landscapes if awakened. Chapter 2. The LASSEN Peak Phenomenon. LASSEN Peak last erupted explosively in 1915, coating distant towns in volcanic ash and demonstrating the power held beneath its slopes. Contemporary studies have detected persistent thermal output and the appearance of new fumaroles, small vents emitting steam and volcanic gases, along the mountain's surface. Geologists equipped with sensitive seismic arrays and gas analyzers have begun to trace subsurface patterns, identifying swells and pauses in underground activity that suggest ongoing magmatic processes. Borehole networks now supply real-time data on pressure, temperature, and gas composition, confirming LASSEN as an active, though currently non-erupting, volcano. The evidence underscores that LASSEN's volcanic system is both complex and alive. While no eruption is imminent, the unresolved pressures deep beneath may one day bring forth new clues to the region's violent history. Chapter 3. Long Valley Caldera, the sleeper threat. East of the Sierra Nevada, the Long Valley Caldera marks one of the largest volcanic depressions on the continent, measuring more than 20 miles wide. In recent decades, this caldera has experienced intervals of increased earthquake activity and the gentle uplift of its floor, known as a resurgent dome. Through satellite interferometry, researchers have mapped fracture networks within the caldera, consistent with gradual magma movement. Newest imaging techniques make use of muon detectors and other advanced geophysical tools to create three-dimensional pictures of subsurface magma, while the analysis of volcanic glass fragments from caldera rocks reveals evidence of ancient, massive eruptions. Further clues come from the region's hot springs, which now bubble with distinctive mineral signatures. While geologists caution that no eruption is forecast, Long Valley remains one of the most closely watched volcanic structures in North America. Chapter 4. Mount Shasta's Icy Secrets. Rising dramatically from the northern landscape, Mount Shasta is crowned by permanent ice fields and shrouded in cloud and folklore. New mapping projects using LiDAR and ground-penetrating radar have uncovered hidden ice chambers and newly formed crevasses, indicators of both glacial movement and localized warming, possibly tied to the volcano's internal heat. Analyses of spring waters and soils at Shasta's base reveal changing geochemistry, specifically an increase in volcanic gas content, suggesting subtle but significant subsurface changes. Archaeological teams, meanwhile, have unearthed traces of early human activity near ancient deposits of volcanic mud flows, evidence that people have long adapted to life at the foot of this volcanic giant, utilizing its geothermal gifts. Ongoing studies blur the line between geological activity and the broader ecological and cultural stories that build around such iconic features. Chapter 5. Medicine. Lake Volcano, forested giant. Hidden beneath the forests of the Modoc Plateau, Medicine Lake Volcano sprawls across a quiet corner of northeast California, covering more surface area than any other volcano in the state. Recent digital topographic mapping has clarified the extensive reach of past lava flows, with vast obsidian fields and old vents now apparent beneath dense pine cover. Speleologists have also identified extensive lava tubes measuring over a mile in length, supporting unique subterranean microhabitats. Biologists wading through the caldera's wetlands have collected peat and pollen samples, which chart the resilience of plant and microbial communities in the face of repeated volcanic disturbance. While the volcano currently shows low levels of unrest, the complexity of its hidden conduits and the memory of past eruptions keep it at the forefront of ongoing volcanological research. Chapter 6. UBEHEBE Crater, Death Valley's young volcano. Within the stark lands of Death Valley, the UBEHEBE crater stands as testimony to relatively recent volcanic activity. High-precision radiometric dating has confirmed its age at less than 3,000 years, making it a geologically young feature. Geological surveys have identified shocked quartz and volcanic ash, evidence of explosive interactions between rising magma and groundwater. Aerial surveys with drones revealed several smaller craters surrounding UBEHEBE, suggesting a sequence of eruptions. These violent phenomena, well preserved in the barren landscape, have also become central to the cultural narratives of local native communities. Research continues into the potential for further activity, with heightened sensing technologies tracing the magnetic and geochemical legacy of this unique site. Chapter 7. Earthquake Mapping. California's living faults. California is dissected by hundreds of active faults, none more famous than the San Andreas. New statewide mapping using satellite-based radar interferometry and ground-based seismic arrays has delivered unprecedented detail of both major and minor fault lines, permitting better predictions of seismic risk. Advanced modeling now tracks the accumulation and migration of stress within these intricate fault networks, helping planners and engineers improve building codes and emergency strategies. Fine-scale maps are essential tools for understanding not only where the next earthquake might occur, but also how water, land, and infrastructure are affected by this ever-shifting tectonic puzzle. As billions of dollars in resources and millions of lives rely on the accuracy of such data, California's seismic mapping effort is seen as critical to public safety. Chapter 8. The San Andreas, a giant bracing to shake. The San Andreas Fault, a boundary stretching the entire length of California, remains both a scientific focus and a cultural icon due to its capacity for large, damaging earthquakes. Recent technological advances have uncovered microquake swarms in segments that were previously believed to be quiescent, forcing scientists to revise their models of how stress and energy accumulate. Field studies have uncovered new evidence of dramatic ground shifts from historic earthquakes, offset rivers and displaced landscapes that reveal how the fault has shaped the state. Subtle chemical changes in groundwater and new sedimentary records indicate ongoing tectonic activity, even during apparent periods of calm. Experts agree that the San Andreas will, at some point, generate another major event. Only by heeding these subtle warnings can the region be sufficiently prepared. Chapter 9. Fossil rebirth after quakes. Earthquakes and ongoing erosional processes have reshaped many of California's canyons and badlands, occasionally unveiling caches of fossils and petrified remains from epochs long past. Following major seismic events and landslides, paleontologists have discovered teeth and bones of mastodons, extinct horses, and giant ground sloths, remnants of ancient faunas that traversed a landscape starkly different from today's. Recently unearthed plant fossils and pollen further expand our understanding of ancient California ecosystems, including the dynamic ways plants and animals responded to past climatic and geographic upheavals. Advances in digital 3D scanning and virtual reconstruction have transformed how researchers document and share these fragile treasures, expanding what we know of the region's evolutionary tapestry. Chapter 10. Ancient forest echoes, remnants in lava fields. Within volcanic fields such as the cinder cone lava beds, geologists and ecological researchers have discovered casts of ancient trees, essentially stone molds preserving the outlines of trunks and branches. Isotopic and microscopic analyses of these fossil impressions and trapped sediments indicate that rich forests once flourished before being swiftly buried by lava or ash. Charcoal and pollen records extracted from these lava beds allow scientists to reconstruct vanished landscapes, including the cycles of fire and regrowth. Some lava fields even acted as refuges, sheltering pockets of life during broader regional devastation. These findings affirm an essential lesson. Even after cataclysmic eruptions, life in California's forests has demonstrated remarkable resilience. Chapter 11. Fluid Earth, Unseen Riverbeds and Aquifers. Beneath layers of volcanic ash and faulted sediment, scientists have deployed seismic and radar techniques to map out paleochannels, ancient riverbeds and underground aquifers long buried beneath modern landforms. These ghost rivers once guided the migrations of wildlife and early humans, and now store critical groundwater reserves. Excavations and sediment coring at some sites have yielded fish remains and imprints of prehistoric water plants, while chemical analyses have revealed traces of ancient flood events. Today, water managers look to these paleochannels for insights into future water sustainability, especially as California grapples with recurring droughts. The hope is not to exploit these reserves heedlessly, but to understand their distribution and recharge rates before considering them as supplemental resources. Chapter 12. The Geological Mosaic, New Bedrock Discoveries. Beneath the visible landscape, California's underlying bedrock is a patchwork of geologic fragments brought together by dramatic plate tectonics. Recent surveys synthesize decades of fieldwork with high-resolution geochemical data to reveal the state's deep foundation, rooted in the piecing together of ancient oceanic and continental crust. Distinct mineral veins and rock types trace the complex story of subduction, accretion, and rifting events over hundreds of millions of years. These bedrock mosaics not only inform our understanding of mineral resources, but provide critical context for ongoing geologic hazard assessments throughout the region. The stories locked within these rocks are essential guides for scientists and planners alike. Chapter 13. Volcanic soils, fertile legacies. In the wake of past eruptions, the breakdown of volcanic ash and lava creates nutrient-rich soils unique to California's volcanic regions. Studies in places like LASSEN and Medicine Lake have shown that such soils support an explosion of specialized wildflowers, mosses, and other plant life not found elsewhere. Soil microanalysis continues to unveil unique ecosystems. Symbiotic fungal networks, adaptable root systems, and resilient moss communities all thrive in the wake of volcanic disturbance. These fertile pockets, though limited in area, are essential sanctuaries for rare species. As scientists study these naturally robust soils, questions arise about the potential for agricultural innovation, balanced with the imperative to conserve threatened habitats. Chapter 14. Archaeological enigmas, ancient human presence. Newly exposed layers at volcanic sites and fault-created excavations have revealed ancient human artifacts, stone tools, hearths, and enigmatic rock engravings. Carbon dating situates some finds in the late Pleistocene, indicating that people occupied California thousands of years before written history began. Finds such as obsidian blades and charred animal bones hint at ancient trade routes and communal activities. Researchers use X-ray fluorescence to analyze artifact materials, shedding light on trade networks stretching across volcanic and non-volcanic terrains. The functions of some markings and artifacts remain mysterious, driving ongoing debate and investigation into the earliest chapters of human habitation in California. Chapter 15. Petrified peat bogs, nature's time capsules. Cores drilled from volcanic valleys in northern California have exposed layers of ancient peat, preserved for millennia by frequent volcanic ash deposits. These organic layers contain pollen, seeds, insect fragments, and bits of charcoal, providing unique records of past ecosystems and climate cycles. Pollen analysis maps shifts between pine, oak, and redwood forests, mirroring environmental changes across time. In certain layers, traces of extinct megafauna have been documented, including imprints of large birds and mammals. These peat profiles serve as natural archives of ecological change and resilience, silent witnesses to periods of drought, fire, and recovery. Chapter 16. Stratified lakes, unusual microbiomes. Lakes formed within volcanic basins, such as those adjacent to Mount Shasta and Medicine Lake, reveal complex layers, distinct thermal and chemical zones that support specialized communities of microbes. Modern limnological surveys using advanced sensors have found anoxic, or oxygen-poor, layers that shelter extremophile organisms metabolizing unusual compounds such as methane and sulfur. These microbial communities, in effect living fossils, help scientists understand both the recovery of ecosystems after eruptions and the persistence of life in extreme environments. Seasonal mixing events in these lakes trigger dramatic blooms of algae, sometimes tinting the water vivid shades. The discoveries raise intriguing questions about the adaptability of life, both in California's past and on potentially similar worlds beyond Earth. Chapter 17. Invasive species and geological disturbance. Quakes, eruptions, and landslides can act as both barriers and gateways for invasive plants and animals. Recent ecological mapping shows how new habitats created by landslides or volcanic flows are sometimes colonized by non-native species, such as Himalayan blackberry, introduced fish, or invasive crayfish. The spread of these opportunistic species impacts native food webs, but also illuminates the ways disturbance, recovery, and biological exchange shape California's unique ecosystems. Scientists and conservationists work together to monitor these changes, striving to protect biodiverse habitats even as landscapes and species shift in the wake of geological events. Chapter 18. Subsurface resources, fossil fuels, and mineral deposits. Beneath layers of ancient lava and sedimentary rock, geologists have pinpointed locations of oil, gas, and unique mineral veins. Careful analysis of core samples and geophysical surveys has revealed the transformation of organic matter under heat and pressure, a process tied inextricably to California's tectonic history. While such resources can provide economic value, their extraction must be balanced against the risks posed to fragile, volcanic, and fault-fragmented environments. Scientists emphasize the importance of responsible resource management as new drilling and mining technologies push ever deeper beneath California's dramatic surface. Chapter 19. Shape-shifting shorelines, coastal processes. California's coastline is constantly in flux, shaped by storms, sea level change, and tectonic uplift. High-resolution LiDAR and drone mapping have made it possible to visualize rapid changes, coastal landslides, eroding cliffs, and migrating beaches, occurring in real time. Field studies occasionally reveal large trees petrified in place, the remains of ancient coastal forests now submerged or buried. Shell middens and other archaeological sites sometimes appear as tides change, and erosion exposes new layers, providing clues to both ancient environments and the lifeways of people who once thrived along these dynamic shores. These continual changes serve as both a record and a warning. California's shore is a place of unending transformation. Chapter 20. Wildlife corridors, adaptation and movement. The movement of land and the creation of new terrains by volcanic and tectonic action have shaped animal migration and adaptation in California for millennia. Recent studies using GPS tags and genetic sampling reveal that bears, deer, and even wildcats use ancient routes, some revealed by the very ground shifts that once seemed impassable. Motion-triggered cameras and genetic sampling show continued, if sometimes precarious, passage for wildlife through rugged volcanic landscapes. The mapping of these paths is now informing conservation strategies, aiming to maintain vital migration corridors as habitat fragmentation increases. In this way, California's deep geological history continues to influence the state's living legacy, connecting the ancient past to a more sustainable future, a place where the interplay of fire, fault, water, and life is both a record of Earth's evolution and an ongoing story of adaptation and resilience. What new secrets will the next landslide, eruption, or shifting shoreline reveal? The answer awaits, beneath our feet, in the curiosity of scientists and the slow, patient motion of the Earth itself. Which of these landscapes or discoveries captures your imagination most? Have you ever witnessed the silent drama of California's restless Earth firsthand? To explore more of the scientific wonders that shape our continent, stay curious and join us again, because the next great story may already be unfolding just beneath the surface.